Dear students, I welcome you all to this course on solid state physics. It will be beneficial to you during your BSc as well as MSc. Let's quickly go through the syllabus that we shall learn during this course, and I will conclude this lecture with recommending you few books. I will recommend books for the students as well as for the course instructors. We will start with the basics, how we define solids, and in solids, what do we mean by crystals, how we differentiate crystals from polycrystalline and amorphous solids, what is the bonding mechanism in solids, various types of bonding, and they are involved with cohesive energy, what is the packing fraction, what percent of a unit cell is used up by the atoms, what do we mean by the Brevis lattice and the 7 crystal systems. To have a look at internal structure of a crystal, we use X-rays and other rays, but we don't get the real crystal lattice. We get the diffraction mapping. That diffraction mapping is the reciprocal lattice. So we shall study reciprocal lattice in detail. Bragg's law, Lave's diffraction. So this we will cover in the basics. Next, we shall move to lattice vibrations. So what are elastic waves? What is the density of states of a continuous medium? Continuous medium means when we have long wavelength waves traveling down the lattice waves, and we shall consider dispersion relation for one-dimensional monoatomic lattice. We shall also study phonons, which gives us the concept of quantization of lattice vibrations. We shall study thermal properties of solids. We will start with specific heat and Dulong-Petit law, which is the classical lattice heat capacity theory, which tried to explain but failed, especially in the low temperature zone. To overcome the drawbacks of this Dulong-Petit law, first Einstein's model and then subsequently Debye model, these two models were put forth, and we will see their theory, assumptions, derivations, expression for specific heat, and their success as well as failures. In the electrical properties of solids, we will start with the Drude-Lorentz theory, which is the classical theory. We shall see its assumptions, what are its various successes, and what is its failure. To overcome the drawbacks of Drude-Lorentz theory, next comes the quantum mechanical free electron theory. We shall study its assumptions and theory, and we shall apply it to deduce expressions for the heat capacity of conduction electrons, electrical conductivity due to those conduction electrons, thermal conductivity in metals due to those electrons. We shall also draw a graph between resistivity and temperature. We shall see how resistivity varies with temperature, and we will come to a concept of Matheson's rule. We shall also study the thermoelectric effects like Joule effect, Peltier effect, Seebeck effect, etc. Continuing, we shall study the band theory of solids, starting with the Kronig-Penney model. We shall learn what are the Brillouin zones and what are the various zone schemas, effective mass, the concept of holes, and how we can explain energy bands on the basis of Brillouin zones. Also, on the basis of those Brillouin zones or energy bands, we will distinguish metals, insulators, and semiconductors. We shall conclude electrical properties with the concept and phenomenon of superconductivity. We shall learn the perfect diamagnetism, that is the Meissner effect, magnetic levitation, London equations, the London penetration depth, what are the type 1 and type 2 semiconductors. We shall learn about BCS theory, Ginzburg-Landau theory, what are the various high temperature superconductors, and also what are its various applications. We shall study also the magnetic properties of solids, Langevin's theory of diamagnetism as well as paramagnetism, von Vlick paramagnetism, Pauli paramagnetism, nuclear paramagnetism, and we shall learn about the process of cooling by adiabatic demagnetization, which is necessary if we want to cool any object below 1 Kelvin. We shall also learn magnetic resonance. Coming to ferromagnetism, we shall study in detail the West theory, the Heisenberg model, the Neal model of ferromagnetism and anti-ferromagnetism, spin waves, and we shall study the novel materials which are called GMR and CMR materials. Now, coming to the books that you shall study. For students, I recommend book number 1 and book number 2. Book number 1 is Solid State Physics, written by S.O. Pillai. Very nice, very lucid, very comprehensive book. And you should also go through the Solid State Physics by Puri and Babbar. For students, I recommend that these two books should be sufficient for you. But for the teachers, course instructors, if you want to increase your horizon, if you want to get in-depth knowledge about solid state physics, then go beyond and also study the elements of solid state physics by J.P. Shrivastava, elementary solid state physics by M. Ali Umar, solid state physics by M.A. Wahab, and solid state physics by Ashcroft and Mermin, and last but not the least, Introduction to Solid State Physics by Charles Kittle.